what we've done in the previous 2 weeks is look at how would a global social planner deal with the climate problem. And before the break, we're going to relax that assumption and look at a bunch of national social planners. And then after the break, we're going to look at what actually happened during the international negotiations and how does theory relate to practice. So that's the plan. This is a very final lecture, and let's start with international cooperation. Taken you through this before, what you would do if you want to optimize something. In a static optimum, you would equate the marginal cost and the benefits. In a dynamic optimum, you would equate the net present value of the marginal costs to the net present value of the marginal benefits. And then you would come up with a cost-benefit diagram that looks something like this. And I said, well, you're going to find an interior solution. 0% emission reduction, keeping emissions as they are, is unlikely to ever be an optimum, but 100% emission reduction, unless you have some very special circumstances, would also probably not be an optimum. So this is the conceptual framework. Then we looked at the marginal abatement costs, and we looked at the marginal damage cost, social cost of carbon, and then we equated the two using, there she is, Nordhaus's DICE model, and we found that the optimal solution is to cut emissions, but not by a whole lot. So we've looked at this particular scenario where there is virtually no climate policy, and this particular scenario where there is a social optimum or a global optimum. Now, 4 years after Nordhaus, top left, published that particular solution, he released, together with Zilli Young, who you see there, another version of the model where they do the same thing, but now as a game between, I believe, 180 countries. They recalibrated the model, so the cooperative equilibrium or the social optimum has shifted from here to here. And I said that before, right, that actually the exact amount of emission reduction, the exact control rate is subject to a whole bunch of assumptions. And it's actually fairly uncertain, and you see that uncertainty illustrated here. Qualitatively, it's the same, right? The global planner would do something about emissions, but not a whole lot. And definitely not enough to stabilize. So this is the cooperative solution, where all countries come together to maximize global welfare. And then the line in between that you see here is what happens if countries only look after their own welfare and only maximize their own welfare and therefore ignore what their emissions do to the rest of the world. And what you see is what you would expect, that if we leave this to national planners, then they would not provide the global solution. They would not provide a global public good, that is greenhouse gas emission reduction. And that follows immediately from the fact what you see here. What you do in an optimum is equate your marginal cost and the marginal benefits to the social cost of carbon. What you're looking at here is the social cost of carbon, or rather the national cost of carbon for, I believe, 25 top countries, right? So the global social cost of carbon in this particular calibration is around 24. Now what you see is that the largest country has a national social cost of carbon of around 3, because the sum is, or the whole is the sum of the parts, right? So if the global is 24, then the national ones must be lower than that. Now, China comes top because it is, so to say, or actually India comes top. But you can't see India because of the projection. India comes top because it's large and poor. China comes second because it's large but not so poor. And then you see a whole bunch of poor countries and large countries following: Ethiopia, Bangladesh, Pakistan, Indonesia, Democratic Republic of the Congo, and Nigeria. So again, it's the poorer countries that suffer most of the consequences. So if all of these countries equate their marginal abatement cost to not the global social cost of carbon of 24, but instead pick 3 as India would do, or 6 as you can't see as China would do, then obviously emission reduction falls. And that is exactly what we see happening in this particular model run. So that is the first insight, right? If you just ignore what you're doing to the rest of the world, you would care less about climate change. The second question you may ask is, so the cooperative solution, where everybody works together, is obviously better for the world as a whole. Can we actually sustain global collaboration? Can we actually get a cooperative solution? I've made all these points. I'm at this particular question here. The question whether or not you can collaborate in providing a global public good is typically looked at through the lens of free riding. It is a bit of a peculiar concept, but let me take you through it. I'm going to return to the linear quadratic model that we looked at before. The costs of emission reduction are a quadratic function, and they are different for different countries. So CI, the cost of emission reduction in country I, is some parameter alpha I times the relative emission reduction rate R to the power 2. The benefits of emission reduction, B for country I, is again some parameter beta, and then times the sum of all emission reductions of all countries, right? Where E is emissions without emission reduction and R is the emission reduction rate. The non-cooperative solution, where everybody just looks out for themselves, is fairly simple. Marginal cost is 2 alpha Ri, right? Marginal benefits, even though you have this sum here, you only control emissions for yourself, right? So for China, what matters is emission reduction in China, but not emission reduction in the USA, because they don't control that. You take your first partial derivative to Ri. So for all Rj's where J is not equal to I, the first partial derivative is 0, right? So the sum disappears. So we simply have beta EI here, and we have a non-cooperative emission reduction rate that is beta I EI over 2 alpha I, right? The cooperative solution, because we assume that emission reduction costs are independent of each other, not entirely true, but let's for simplicity do that. But the benefits are obviously depend on what other countries are doing, right? The total benefits to any country depends on the total emission reduction across the world, not just emission reduction in their own country. So instead of having the beta, the Bj here, we now have the sum, or the Bi here, we now have the sum over the benefits. So essentially what you do in the cooperative solution is that you take the first partial derivative of the benefits that fall on yourself through your own emission reduction, but then you add the benefits of your emission reduction on all other countries, right? And then you get the sum of the beta j's, not just the marginal benefit to yourself, but the marginal benefit to everybody else in addition, right? But as I said, we assume that the costs of emission reduction are independent of what other countries are doing, so this stays the same. And then what we have is that the cooperative solution, R prime, is beta EI over 2 alpha I. And this looks very, very similar to what I had before, right? Before I had beta I, and now I have beta, where beta is the sum of the beta i's. So structurally it looks very similar, but the beta is very, very different, right? The beta now includes all betas, not just your own beta. The difference in costs between the two solutions, so the cooperative solution and the non-cooperative solution, is this thing here. We had a quadratic function, right? So we take the r and simply raise it to the power 2. So we had an alpha here as well, so that cancels. So we have beta squared e squared over 4 alpha. And then this is for the cooperative solution, non-cooperative solution. We have the same thing, but now we have a subscript I. So essentially the difference in costs is a scaled difference between the total marginal benefit squared and the marginal benefit to your own country squared, right? That is essentially what drives the difference in costs. The difference in benefits of free riding, not if free riding. Oh no, the difference in benefits if free riding is as follows. Now, I've been talking about free riding, but I haven't defined it, right? So free riding is defined somewhat peculiarly as the initial situation is where everybody collaborates. So all countries come together and jointly maximize global welfare. Then free riding is you assume that the rest of the world will continue to collaborate, but you leave the coalition and you just maximize your own welfare. But the assumption is that the rest of the world will continue to collaborate. Now the benefits of doing so is well, the rest of the world continues to collaborate. So really what matters is how much your emission reduction changes as a result, right? Because the rest of the world will continue to do what they've always done. So the benefit or the change in benefits is this thing here. It's the change in your own emission reduction rate times your own emissions and times your own impact parameter. So this is beta I times beta minus beta I, and then again a scaling term. So now we have shown that free riding is almost always optimal, right? It's almost always in your own self-interest, because obviously this thing is always larger than this thing. Now, for those of you who it is not so obvious to, let's look at some numbers. So I'm going to assume that emissions are 1 and alpha is 0.5. So this is 1, this is 0.5, so here we have 1/2 and here we have 1, right? That is why the numbers are as they are. Let's assume that the global social cost of carbon is 4 and the national social cost of carbon is 1. So you're 1/4 of the problem, right? Then the difference in costs is beta squared minus beta I squared. So that's 4 squared minus 1 squared is, I believe, 15, right? Divided by 2, right? Because this is just 1, so this is, yeah, this thing is 1/2, right? So that the difference in cost is 7.5, right? The difference in benefits, this thing here, 4 minus 1 times 1 is 3, right? So if you're 1/4 of the problem, then the cost savings from free riding are much larger than the loss of benefits, right? The additional impact of climate change. So that if you're 1/4 of the problem. If you're 1/10 of the problem, then the following numbers pop up. So 10 squared minus 1 squared is 99, divided by 2 is 49.5. cost savings actually go up quite a bit. The benefits also go up. It's 10 minus 1 times 1 is 9, right? So if you're a smaller part of the globe, then actually it pays more to free ride. Because the rest of the world is so very large to you, you actually do a lot of your in-house emission reduction is on behalf of the 90% of the rest of the world rather than the 10% in your own country, right? So smaller countries have a stronger incentive to free ride. So I went the wrong way, right? I should have made the country bigger, not smaller. So that is what I do in the middle here. Now the country is responsible or suffers half of the global social cost of carbon. So it's 2 versus 1. That's 2 squared minus 1 squared is usually that's 3 divided by 2 is 1.5. 2 minus 1 times 1 is 1. So even if you are 1/2 of the problem, then you would still want to walk away from the global coalition. It's still in your interest because the cost savings of doing so are 1.5. The additional impact of climate change is only 1. So it is in your interest to walk away.
So we're comparing change C and change B.
Yeah. So this is a rather sobering insight, right? And of course this is a calibration, right? You can do it slightly different, but it doesn't really matter what you do. It is almost always the case that you would want other countries to collaborate and collaboratively reduce their emissions, but you would not want to be part of this, right? Now, if it is the case that it is in the interest for almost all countries to walk away from the global coalition, then the global coalition collapses, right? And there's nothing left. Now, there is a bit of a twist to this. So what I just did was compare the situation in which all countries work together versus nobody working together. The question that you may have, well, is there an intermediate form? Could it be that a smaller group, a smaller number of nations comes together to collaborate? And for that we need to look at, or the way this is usually done, is through cartel formation. As the name suggests, this comes out of industrial organization. This is, can companies come together to form a cartel with market power? And this has also been applied to countries in the case of providing greenhouse gas emission reduction. And this goes back to the guy you see there, Claude Daspremont, who did the theory of this in the late 1970s. And he introduced the following. He was interested in coalitional stability. That is, can a group of countries or companies come together in a way that is stable, where they would not have a reason to walk away from the coalition or the cartel. And he had 3 sub-definitions for stability. First, he was interested in profitability. Is the coalition, the cartel, better than the NAS equilibrium where nobody collaborates? For all those in the coalition, right? We don't care about the people outside of the coalition, but we only care about the people inside the coalition. That's the first condition. The second condition is whether the coalition or the cartel is internally stable. That is, no member wants to walk away. Seems a reasonable condition for stability. And the second is external stability. No non-member wants to leave, right? No non-member wants to join. Thank you. which also seems a reasonable condition for stability, right? The Grand Coalition, where everybody works together, is by definition externally stable because there are no outsiders, right? A profitable coalition of 2 players is by definition internally stable, because if it's better than no cooperation at all, then no player has a reason to leave, right? So these are the 3 conditions for stability. Now, how does this work? Well, essentially what happens if you join a coalition, then you start paying attention to the impact of your emissions on other countries. And assuming that the impact of climate change is negative, and it's negative everywhere, then that means that you have to cut your emissions harder, because the marginal cost that you're now looking at is no longer the marginal cost to yourself, but also the marginal cost to others. And you're still equating it to the marginal cost of climate change is now higher, the marginal benefit of reducing emissions is now higher, but you still compare it to the marginal cost of reducing emissions, right, which has stayed the same. So if you join a coalition, then essentially you have to work harder, right? And you would wonder, why is this the case? Why would you do this? Well, because the other people in the coalition have to reciprocate. They now need to take into account what the effect of their emissions on you is. So they also need to work harder, because their social cost of carbon has also gone up, right? So let's look at this. Returning to our simple game, simple linear quadratic game. I have 2 players only. That's all we need to show what I need to do. So instead of Ci, I now have C1 and C2. And instead of Bi, I now have Bi and B2. And instead of this summation sign, I now just written them out, right? Because there's 2 only. But nothing has changed. The non-cooperative solution, you create the marginal cost to the marginal benefits. So we have that the non-cooperative emission reduction is beta 1, E1 to alpha 1 over 2 alpha 1. And for R2, it's exactly the same, but now the 1s are 2s, right? And this is the same as we had before, but we had i's instead of 1s and 2s. The cooperative solution is that you take the first partial derivative of the sum of the costs, but C2 does not depend on R1, so nothing has changed here. Sum of the benefits, we again have that my emissions do not just affect myself, but also affect the other player, right? So we have beta 1 plus beta 2. So the optimal solutions optimal cooperative solutions are beta 1 plus beta 2, and then the same scaling constants that we had before. Now, so essentially what happens, for our star we had beta 1, E1 to alpha 1. Now we added beta 2, right? So that is the difference between cooperative and non-cooperative. And the same here, but of course then beta 1 disappears rather than beta 2, right? So the difference in emission reduction is the other marginal costs, your emissions and your emission reduction costs, and here again the others marginal costs, right? That drives the change in costs, and that drives the change in benefits. You can write it out as here. Essentially the condition is, I mean, what you want in this game is you want to do a little bit extra, right? Because if you do only a little bit extra, then the increase in costs is small. And you want the other to do a whole lot more, right? So that the benefit to you is fairly large, right? It's only when the benefits of collaboration are greater than the costs the additional costs of collaboration, that you would want to join the coalition, right? So if your benefits are greater than your costs, then the coalition is a good prospect for you, right? Now that happens if after joining the coalition, you reduce your emissions by a little bit more, but only a little bit more. And if you do it by a little bit more, then the change in cost is fairly small, right? And if the other then in return cuts their emissions by a lot, then you have a large benefit, right? So that is what you would like. But of course the other player wants the exact same thing, right? They want to reduce their emissions by a little bit extra and hope that in return you cut your emissions by a lot extra, right? So there is very little to play here, right? Because the incentives are just misaligned. Now, the first to point this out was Carlo Carraro, who you see there in his younger days. And a key point here is essentially what we're doing here is barter trade, right? I have beer, you have pizza. I want to give a little bit up a little bit of my beer and get a lot of pizza from you, right? And you want to get a lot of beer and give up as little pizza as possible, right? It's barter trade. And it's strictly barter trade because there's no production. There's actually very little that can be done. So Carraro was the first to point this out. Scott Barrett, who you see here at the bottom, took this a step further. And even though the suggestion that I make here is that there is very little to play for, and therefore the sort of the stable coalition would be fairly small because there's very few countries where you would actually find that all these conditions are met. Barrett showed that there's a second solution to this game. So the first solution is the one that I suggested, that virtually nobody has a reason or an incentive to collaborate. Barrett showed that there's a second solution in which a lot of countries collaborate, but they essentially agree to do almost nothing, right? Then you also have so you either have a small, stable coalition that is fairly ambitious, but because the coalition is small, it doesn't do anything for global emissions, right? Or you have a large coalition with a large number of countries coming together, but they do almost nothing. So again, global emissions would be hardly affected. So far for theory, right? And this goes back to Economics 101, right? What we're trying to do is provide a global public good, and it is hard to provide public goods without a strong government. So, how does the predictions of game theory relate to what happened? And actually, I'm not going to stop at Paris. I'm actually going to go all the way to Glasgow. I added the material for Glasgow, but I did not update this. So, where are we with international climate policy? Well, I think it is summed up here that international climate policy has a long history of good intentions. What you're looking at here is on the vertical axis, we're looking at the atmospheric concentration of carbon dioxide in the atmosphere over time. That's on the horizontal axis. Then the colors that you see are the global mean surface air temperature, where blue is cold and red is warm, and very dark red is very, very warm, right? I haven't shown this, but you've seen things like this. And then the points that are marked here are various various international events. So the first World Climate Conference was in 1969, no trend break. First IPCC report was in 1990. The first COP1 was in 1995. Kyoto Protocol entered into force in 2005. Again, you see no change in concentrations, right? No trend break. Copenhagen Accord, Paris Agreement. The long history of good intentions, right? But no discernible impact on the atmospheric concentration. So what happened? So anthropogenic climate change was first described by this guy, the Nobel laureate Svante Arrhenius. He won his Nobel Prize for other stuff. First described in 1896, right? That's a while ago. That's 126 years ago, right? But at first it was sort of a curiosity that meteorologists and geologists knew about, but it wasn't really in the public mind or in the scientific mind, for that matter, until the early 1980s, when the first measurements of CO2 in the atmosphere became available, or the first long time series, and the first longer time series of the temperature became available for the world as a whole. So then people started realizing that the world was indeed warming. This was done in the early 1980s, the late 1970s. And politicians started paying attention fairly quickly. Already in 1984, in 1985, politicians started sitting up and said, oh, there's something going on. And of course, the first senior politician to do so was your favorite Margaret Thatcher. And that led to the United Nations Conference on Environment and Development in Rio in 1992, where a whole bunch of international treaties was negotiated, I believe 5. 3 of them quickly died. One is still going, the Convention on Biodiversity, and the Conference of the Party was just this week. And the other one that was negotiated was the United Nations Framework Convention on Climate Change, right? And we talked about that before. But it was negotiated in 1992, a resounding success. Within 3 years, it was entered into force, was ratified by almost all countries. There's a few holdouts, North Korea, the Vatican, but that's it. And why was this? Because it's a framework convention. It actually doesn't do a lot. It just says negotiate. It's essentially what the UNFCCC does. And that is something that is unobjectionable for a great many countries. I said they didn't do a whole lot except sort of set the ground rules for climate negotiations. But there's 2 things that the UNFCCC did do. One we talked about already, the other we did not. Emily noted that my slides are still in German, right? This is German, this is not English. The UNFCCC acknowledges that there are common but differentiated responsibilities. So common responsibility means that climate change is a global problem and it's caused by all our emissions put together, right? That is what common responsibility means. Differentiated responsibility means, yes, but rich countries emitted most in the past, so they are primarily responsible. And essentially this is diplomatic speak for saying the OECD, the club of rich countries, created most of this problem and therefore they should take the lead in solving it. And this, of course, has been the mantra ever since, right? You first. The second thing that the UNFCCC established is that concentrations should be stabilized, and we talked about that 2 weeks ago, right? But other than that, the UNFCCC essentially started a series of negotiations, and negotiating is what they have been doing. So it entered into force in 1995. There was one meeting, 900 people attended. In that one meeting, last month in Sharm el-Sheikh, there were 47,000 people at the negotiations, right? 47,000 people trying to agree on something. And it's not just that there was one meeting under the UNFCCC this year. It actually started off with one meeting in 1995. Then the negotiations became a little bit contentious, so what they did was, instead of having an annual meeting, they had a biannual meeting, that is, meet in November, but then also meet in June, so it's sort of to prepare, and that became not enough time to talk, so that became, now they come together every 3 months. And of course, you have this large meeting, so the first thing that they do is create committees that have to meet, and then those committees create subcommittees that have to meet. And these are diplomats, right? And these are bureaucrats, so what they do is produce paper, and they create acronyms, and they create initiatives, and they do this and they do that, and all the committees and the subcommittees and the sub-subcommittees. So it's not just that the number of meetings proliferates, but by now it is just such a complex thing that they now also organize training meetings for people to understand what is going on in the meetings, right? So by now we have something like 75 meetings per year. That is 3 meetings every 2 weeks where people come together, right? So the cost of all this has grown quite substantially. Of course, the pandemic did something about that, not necessarily good. So, what happened at these meetings? So in 1995, the very first meeting, there was almost an agreement. That was in Berlin. Then they needed a breather. 1996, nothing much happened. In Kyoto, there was an agreement on emission reduction. And the Kyoto Protocol, that is Kyoto there, specifies 2 things. One, it specifies targets for emission reduction for essentially all countries. And it agreed on flexibility mechanisms, so international trade in permits. Now, this is still in force, but it's never used. Oh, no, that's not true. I'll take that back. This is still in use. Emission reduction targets were for the year 2012. The Kyoto Protocol was hailed as a big success, 1997. Within 3 years, we have a deal, right? And we have agreed on emission reduction targets. But the Kyoto Protocol did not specify the definition of emissions. So it said Europe has to cut its emissions by 12%, but it did not say 12% of what, right? It also did not specify what happens if you do not meet these targets, right? So those were 2 big gaps. So they met a year later in The Hague. The Hague is there. Big dust-up, not the usual dust-up that you would expect, or that we've come to expect now, because at that time Clinton was in the White House, and Al Gore, the famous climate warrior after he left office, was representing the United States. And Gore was sitting for 2 weeks in The Hague, twiddling his thumbs, because there was nobody to talk to, because the English, the Germans, and the French were fighting with each other about what to tell poor Al Gore. The Europeans learned from this, and ever since the Europeans go in with a pre-negotiated negotiation stance, right? So the Europeans now speak with one voice, but because Europe is democratic, regardless of what Farage may say, that is publicly announced and everything. So the EU essentially goes in with a pre-negotiated and pre-announced position in the negotiations, essentially excusing themselves from the negotiations. So that was in The Hague. A few months later, George Bush was elected. Some people say he was not elected, but he definitely took office. And the US essentially lost interest in climate policy. That's actually this guy here, Cheney Sr., who did it rather than Bush Jr. So they came back a year later in Marrakesh, what you see there, and they reached an agreement on how to measure emissions, and they did it very, very generously. They also reached an agreement on enforcement. What happens according to the Marrakesh Protocol if you miss your targets? Well, then you have to do 25% more in the next round of negotiations, but it's 25% of a yet to be identified and yet to be negotiated number, right? So essentially there was no sanction imposed. And a few countries got more relaxed targets. The US walked away, nonetheless Canada walked away, Australia walked away, and the Kyoto Protocol only put binding emission constraints on Europe, Western Europe, and on Japan, right? Japan could not walk away because it was it was the Kyoto Protocol, right? So they could not walk away. And both Japan and the European Union met their targets basically because of lack of economic growth rather than climate policy. So that was the first attempt. Not particularly convincing. The Kyoto Protocol went into force only in 2005. So then the attention turned to trying to negotiate a successor to the Kyoto Protocol. There was an agreement in Bali to agree by 2009, and that was the conference in Copenhagen, where a lot of people went there. Copenhagen is there. A lot of people went there expecting that a deal would be made. And you can go on YouTube and look at some of the videos there. Barack Obama was there, Angela Merkel was there, what's his name, who preceded Macron was there, Gordon Brown was there, right? All the Chinese sent their prime minister rather than the president. All these very senior politicians were there, which sort of indicates that, yeah, really something is gonna happen. But it didn't, right? Because even though there was this hype that we're gonna agree, it turned out that it's actually very hard to agree on emission reduction targets. And at one point, Barack Obama just stormed out, right? And said, well, I'm not gonna talk to the Chinese anymore, I'm not gonna talk to the Europeans anymore, I'm gonna talk to the South Africans and to the Brazilians, and I'm going to agree, actually China was there, I'm going to talk to China and Brazil and South Africa, and we're going to agree on a deal, right? India was there as well. And they actually came up with an agreement, but then Pakistan looked and said, yeah, but India was at the table, but I was not. So I don't agree. Argentina said the same thing, right? Nigeria said the same thing. Who appointed the South Africans to negotiate on behalf of the whole of Africa, right? And of course the Europeans were also deeply offended that they just walked away. But the reason was, of course, that Europe's position was fixed and pre-announced anyway, so there was absolutely no point to talking to the Europeans. Or so Obama thought, right? So we had a deal that lasted for about 24 hours and then all hell broke loose. And essentially there were, you probably don't recall that, there were major demonstrations across Europe about the shame of Copenhagen. They met a year later in Cancun, agreed to continue to negotiate, and then they met in Durban, and they met in Doha. I'm now losing my Bali, Cancun, Durban, Doha. They essentially agreed to continue talking for 6 years, for 3 years after Copenhagen. That was the best they could do. Things changed, and then we're going to break in Lima in 2014. And there you have Lima. In Lima, what happened was that essentially the aim of the international negotiations of the previous 20 years was abandoned. So from Berlin to Copenhagen to Doha, the aim of the international negotiations was to come up with legally binding targets for emissions for every country. And it turned out that that was impossible. And in 2014, they realized that, and they replaced it with this awful term, intended nationally determined contributions to climate policy. Right? That's a bit of a mouthful. You need to be a diplomat to come up with such nonsense. There's two keywords here. One, they are nationally determined. They are not set by international law. This is not a United Nations mandate or anything. No, this is set by, in the UK, the House of Commons. In the EU, it would be the European Parliament and the European Council who set these targets. In China, it would be Xi Jinping who sets these targets, right? This is how decisions are made in my country, and that is the rules we're going to follow, right? Nationally determined. Intended means that we hope to do this, we aspire to do this, but we are in no way bound by this other than through our honor, right? This is what an economist would call a pledge and review system. And pledge and review systems are not very good, but they work, right? So what happens if a civil war breaks out somewhere in Africa and we need to send peacekeepers? What we do is we organize an international jamboree, right? Where everybody goes around and says how awful the situation is. And then we go around with a begging bowl. And Japan would send money, and Pakistan would send troops, and the US would send logistical support, and then you have your peacekeeping force, right? What do you do when you have an outbreak of a nasty disease like Ebola? You organize an international jamboree where everybody says how awful the situation is and how much worse it could get. And we go around with a begging bowl, and Germany would send money, and Japan would send doctors, and India would send nurses, right? And you have your medical intervention there. That is how we, in practice, provide global public goods. Voluntary contributions from countries. And that is essentially what the Lima Agreement does. We go around with a begging bowl and ask China, what are you prepared to do? UK, what are you prepared to do? Right? And then we hope it is enough. And then, in this case, 5 years later, you come back and say, was it enough? Should we do more? And you keep on doing this until hopefully the problem goes away. It's tried and tested. It's not perfect. It's far from perfect, but at least you can get something done. From a game theory perspective, if you're a rational actor, right, if you face the prospect of a legally binding target on your emissions as the outcome of the negotiations, then you go into those negotiations very, very cautiously. You will not promise too much, because that may come back to bite you, right? If you go and it's only an aspiration that you express, and you keep control in your own country, right? There's no transfer of sovereignty to the United Nations, then you can be much more honest and much more ambitious in your pledges, right? So this system is actually preferred. I ended with the agreement in Lima. Now the problem with Lima is that it's in a poor country, so an international treaty cannot be named after its capital, right? So essentially the agreement in Lima was codified in the Paris Agreement, and everybody calls it the Paris Agreement, even though the deal was done in Lima. Now, Paris did another thing. It essentially agreed on targets for the global mean surface air temperature and its maximum change, 2 degrees maximum, and if you can keep it to below 1.5, then that would be great. We talked about these targets before. But even though there is a global target, it's fairly meaningless, there are no national targets, right? And the global targets were essentially put in there to placate the Greens, right? We give them something to be happy about, but in fact we did not agree to what countries should actually do to meet those targets. There's one implication of this, of the intended nationally determined contributions, is that there is no legally binding framework anymore. Countries are obliged to do what they want, essentially. That is what the Paris Agreement does. And that means that a previous tactic that a lot of developing countries used, that we disagree with this target, we disagree with this agreement, we disagree, and richer countries were hoping for their agreement all the time. And in order to buy them off, they always offered a lot of money. Did not really follow up by giving it, but always promised money. Since Paris, because there is no longer a global deal, essentially, there's just a series of national deals, and it's essentially all procedural rather than substantial, developing countries lost their leverage. You cannot block a deal that doesn't exist, right? And has no intention of existing. And therefore, the promises of money disappeared. Now it is true, and we talked about this before, that last month in Sharm el-Sheikh, a loss and damage mechanism was introduced. But so far what was done was a promise to talk about this rather than a loss and damage mechanism. No money has been put in there and liability has not been established. Before we look a little bit closer at the Paris Agreement, there's one thing I need to say. Last year in Glasgow, we saw the first shift away from the temperature targets, which is meaningless, right? No country can control the global atmosphere. So you can set a global target whatever you want, but nobody has control over this, so it's a pointless target, right? It's like me talking about how the Dutch will perform on Friday afternoon, right, against Argentina. I have no control over this. I can say whatever I want about this, but I have absolutely no control, unfortunately. The same is true for the global mean surface air temperature. That's beyond everybody's control. We talked about this before. If you want to stabilize the CO2 concentration in the atmosphere, then emissions have to go to zero, right? Now, emissions cannot go to zero unless every country's emissions go to zero, right? And in Glasgow, we have seen a shift in language towards that the goal is no longer temperatures, the goal is no longer the atmospheric concentration of CO2. No, the goal is now becoming zero emissions everywhere, right? And that is something that a country has control over, right? You may not have control over the emissions in China, but you do have control over the emissions in the United Kingdom. Now, what does the Paris Agreement say? Each party shall prepare, communicate, and maintain successive nationally determined contribution that it intends to achieve, right? Nationally determined intention. Parties shall pursue domestic mitigation measures with the aim of achieving the objectives of such contributions. So essentially this says every country must have a climate policy, right? That's essentially what it says. 4.3 is perhaps a little bit more stringent. Each party's successive nationally determined contribution will represent a progression beyond its previous plans, right? So the new plan has to be better than the previous plan. But better is not defined, right? It just says it has to be a progression. So it can just be printed on glossier paper, for instance, right? With more buzzwords in. A party may at any time adjust its existing contribution with a view to enhancing its level of ambition, right? This is what is called a ratchet. So you start with promising a little, but the next promise that you make has to at least look better, right? Then every 5 years there will be a global stocktake, and the global stocktake, the current global stocktake is expected for next year, I think. The first global stocktake is expected for next year, but we've seen preliminary stocktakes, and what we notice is that countries have promised more than they do, and what they have promised is not enough, right? And that is what next year and the year after the UNFCCC will formally conclude and recommend that all countries work harder. If you miss your targets, then we're talking about compliance, right? You promised something and you didn't do it. Compliance will be done in a manner that is transparent. That's good, right? Non-adversarial and non-punitive. Non-punitive, right? If you miss your targets, then no sanctions will be imposed on you. That's what non-punitive means. Non-adversarial means that you can't even ask pointed questions, right? So there will be a committee that will look at the plans of the United Kingdom and say, well, in 2016 you promised to cut your emissions by 30%. Then the global stocktake will tell you, but emissions fell only by 20%. Then the committee cannot ask, now I'm at a loss, who is the current responsible minister? But let's call him Sunak, right? They cannot go and say, Mr. Sunak, you promised 30%, but you did only 20%, how come, right? That would be an adversarial question. Even that is not allowed, right? You cannot put egg on people's faces. So it is pretty weak, right? This is very, very weak. And then on top of that, a party may withdraw from the Paris Agreement at any time, which is of course exactly what President Trump did. Biden reversed this. So, where are we? I talked about game theory, and that it predicts that it will be very difficult to negotiate an international treaty on greenhouse gas emission reduction because it is a public good. And we now have 30 years of experience showing that yes, this is indeed very, very difficult, right? So from an academic perspective, this is good, right? We predicted something, and I showed you Colacoraro's face before. He predicted this in 1992, right? Before all this started, that it will lead to nothing. So Carraro is happy that his predictions came true, but not so happy with the outcome, right? So good from an academic perspective, bad from any other perspective. Now, half an hour, 35 minutes left. There are 2 international treaties on the environment that were pretty successful on acidification and on the ozone layer. And acidification is so successful that you guys don't even know what it is anymore, right? So let's look at these two and see whether their success can be transferred to climate. And unfortunately it cannot. Let's first look at acidification. So, for those of you who were born after the year 2000 in Europe, acid rain comes from sulfur and nitrogen that is released when you burn coal and oil. As I said, you do that to get energy out, and that's why you want to split the sea from the Hades. But typically these things come with contaminants in, and two of them, or one of those contaminants is sulfur, and then atmospheric reactions also gets you nitrogen. That leads to particles in the atmosphere that are acids, and they come down, not just through rain, but they actually come down when it doesn't rain either. The problem with this is that it kills trees, it kills fish, does damage to a whole lot, bunch of ecosystems, because it's an acid. It sort of melts limestone, right, which is calcium, and a lot of monuments are built from that. And it increases, or it creates a haze, so it reduces visibility, right? So acid rain is bad, right, and we want to get rid of that. And there was actually an early agreement already in the mid-1980s to cut these emissions. What I forgot to say is that these acidifying particles don't travel across the world so much because they rain out or they fall out of the sky, but it typically takes 14 days or so, and in that time they can cross a continent, right? So the emissions in the UK fall on Poland, and emissions in Spain fall on Germany, right? So that is sort of the scale that you need to think about. It is not that our acidifying emissions affect China directly. That's too far away. So it's a continental problem. There was agreement in, I believe, 1985 to cut emissions, and later that agreement was strengthened, and later on it was strengthened again. And what we have seen in Europe, and that is the red line that you see here, is that acidifying emissions went up and up and up and up and up, and then they came down, and it stops here in 2002 or 2003, but have continued to fall ever since. This was a successful intervention, right? And the question then is, how come? How can it be that emissions fell, that policy was successful? Because after all, it's not a global public good, but it is a continental public good. So in Europe, acid deposition has been falling. The same is true in North America. The same is true in Japan, right? Well, there are 5 reasons here. First are co-benefits. I've talked about co-benefits before, but in this case the co-benefits are pretty strong. So the pollutants and the sort of stuff that creates acid rain, sort of a continental problem, also create a lot of problems with urban air pollution. And the measures that you take against urban air pollution also just happen to reduce acidification, right? So that was a big reason to clean up snow. Another reason is that a lot of people were worried about this, and there is actually a recent word in English that is borrowed from German, and it's called Waldsterben, which is now an English word, not just a German word anymore, which means the dying of the forest. The Germans have this sort of mythical adherence that they all came from the forest, and that is sort of like where we're from, and that's where we want to be. And the idea that the trees would all die really, really created a strong public demand to prevent this, right? The word Waldsterben in English now means that, yeah, there is this public scare, but it isn't really real. But in the 1980s, people believed that trees were dying because of acid rain. We now know that they were dying because of drought, but people did not believe that at the time. So there's a strong public demand for action. And actually, the way to get rid of the sulfur and the nitrogen is by putting catalytic converters in cars, right? That takes out the nitrogen precursors, and by putting scrubbers on smokestacks of coal-fired power plants, where you essentially remove the sulfur. And we talked about the scrubbers before, because they also increase CO2 emissions, right? And these things were not excessively expensive. So a catalytic converter in your car sets you back 350 pounds, right? Then you also need to change gasoline to non-leaded, and that is a few cents more expensive per liter, a few pence more expensive per liter, but that's it. This is not an excessively expensive technical fix. Putting a scrubber on a power plant raises the price of electricity by 30% or so. So this is not hugely expensive, right? So strong public demand. You have a technical fix, not that you have to live in the cold or something. You can fix the problem. Electricity bills go up slightly, but that is fine. It helped, of course, that at that time the electricity generating sector was still state-owned and state-run, right? So these were monopolies essentially, and they did not care about the additional cost because they could just pass it on. Right? And essentially it was one part of the government telling another part of the government what to do, which is much easier than the government telling private industry what to do, right? So all this helped. Another thing that helped is, here she is again, Margaret Thatcher, right? That coal was essentially on its way out and was being replaced by gas. So we saw first in the UK, later elsewhere in Europe and the United States, privatization of power generation. So at first they absorbed the cost, and then they actually became cost conscious because of competition, and then said, oh, coal is expensive, let's switch to gas. Nothing to do with the environment, everything to do with competition, and it just so happened that we switched to gas, and gas was a lot cleaner, right? And then the final thing that happened was that the Berlin Wall came down, the Soviet Union fell apart, and as a result, the industry and the economy and the industry in Eastern Europe, which was extremely dirty, collapsed. And the so-called Black Triangle in Poland, Czechoslovakia, and that other country that I now forget, Eastern Germany, Poland, and Czechoslovakia, right, was extremely dirty at the time. All that industry, all that heavy industry, a lot of steel industry, a lot of coal, that essentially completely disappeared in a space of a few months. And that took away a big part of the acidifying emissions, right? So yes, there was policy. There was an European agreement to cut emissions, and this was done at a time that European countries were still basically sovereign in this regard. The European Union did not have strong powers over the environment. It does now, but it did not then. There was an agreement to do something, but really most of the action just came by happenstance rather than because of policy, and we just hit those targets by accident. The hole in the ozone layer is a bit more involved. There's two things going on there. So, what is the hole in the ozone layer and where does it come from? Somewhere in the middle of the 20th century, people invented so-called chlorofluorocarbons. carbons. And most people find that difficult to say, so they call them CFCs, right? Now, CFCs were the best thing since sliced bread. CFCs are essentially inert chemicals. And they could be used as refrigerants and solvents and propellants and so on and so forth. And the fact that they were inert was actually thought of as great, right? Because if you use them in a fire extinguisher, right, they're inert chemicals, and you can use them to extinguish fire, which is a good thing. But because they are inert, you can just put the fire extinguisher there, and 20 years later, it still works, right? If you use it as a propellant for deodorant or something, you just put it in the can, and then 20 years later, you still have a functioning deodorant, right? So you just build up inventories, do not need to worry about wastage. Same is true if you use it as a coolant, whereas in your car you every so often need to replace your oil. You never replace a cooling liquid in your refrigerator, right? It would be rather dirty and rather awkward, but you don't have to do that. These are inert chemicals. So absolutely brilliant, people thought. And because they were inert, at the end of the economic lifetime of your fridge and your fire extinguisher and so on and so forth, you could just dump these chemicals into the atmosphere because they did not react with anything anyway, right? They were just completely innocent. Or so people thought. When the CFCs go up high into the atmosphere, they are hit by ever stronger solar radiation. And if CFCs are hit by UV radiation, then they become very nasty. They are not destroyed by UV radiation, but rather they go into a, God, words escape me today, a catalytic chemical reaction. And essentially what happens is that a CFC atom interacts with an ozone atom and UV radiation, and as a result the ozone atom is destroyed, but the CFC atom survives and can actually destroy 200,000, 300,000 ozone atoms high up in the atmosphere. Now, you may have heard of ozone and you think that is bad, and it's true, ozone is bad when you breathe it in, right? And it's worse for crops. But high up in the atmosphere, ozone keeps out UVB radiation. And we have a layer of ozone up there that essentially makes sure that the most harmful radiation from the sun does not reach the surface of the planet and does not hurt us. So if you destroy ozone, you get harmful radiation, and that essentially causes the most thing that people are most worried about is that it causes cancer, right? Particularly skin cancer, but it does not just affect humans, it affects essentially everything, right? It can lead to DNA changes and so on and so forth. Pretty bad stuff, right? So, this was recognized, I think discovered in 84 or 83. In 85 there was an international conference, a political conference, where people said, yeah, this is a problem, we need to do something about it. And they agreed not to do something about it, but to share information, right? And to share and to continue to meet. Now they reconvened 3 years later in Montreal. And in Montreal, they essentially agreed to phase out production and consumption of these things. And ever since, there have been meetings, and the Montreal Protocol has been amended 5 times. And those amendments had 2 effects. One, the phase out, the zero emission, was brought forward in time. And whereas the initial agreement had 24 signatories, later agreements had more signatories. And by January 2001, consumption and production of CFCs is forbidden in the OECD, and by now it's actually forbidden in most countries. And this has been fairly successful. Here we're looking at those emissions. You see them go up and up and up and up and up because people thought it was brilliant. Then we discovered that we have a problem. Montreal Protocol takes effect. And you see emissions come down and down and down and down and down. And this actually ends in 2014. They have come down further. And what you see, there's actually not a hole in the ozone layer. This is a depletion of the atmospheric concentration. You see is that indeed the ozone layer gets thinner and thinner and thinner and thinner, and it's now beginning to recover. And by 2050 or so, we expect it to be back at its old level. So this is a big success, right? This is I pressed the wrong button. How come, right? This is a global public good. Acid rain is a continental public good, and I talked about Europe. Those Europeans, they want to agree anyway. This is a truly global public good. So why was this successful? Well, the first thing is that again there is a strong public demand. There was a strong public demand, and that's mostly because whenever you use the word C word, whenever you use the C word, cancer, then people sit up and start paying attention, right? And so there was a public demand to solve this. The second reason is given here. So what happened in Montreal, right? So in the run-up to Montreal, people were pretty pessimistic, right? They said, well, this is a global public good. There's no way countries can agree on this. And these international things always last 2 weeks. So in the first week of the Montreal negotiations, people were just politely saying to each other, yes, this is a problem, but you go first in solving it, right? Not me, right? And they were just going around making polite noises for a week. And that actually lasted into week 2. And on the Wednesday evening of Montreal, the following happened. The CEO of DuPont called up the White House and said, look, Ron, we cracked it. Now you negotiate us a deal. And on Thursday, so this was early, right? So the White House sends a fax to Montreal. And on Thursday, the Japanese and the Europeans were completely flabbergasted because the Americans all of a sudden switched position. They wanted a deal, and they wanted a strong deal. And they were so flabbergasted that they just signed up to all the American demands. And that is what we had. And essentially what Montreal did was said, no more CFCs. Now, why would DuPont do this? And why would Ronald Reagan, who is a pretty conservative Republican, go along with this? DuPont is a big chemical company. DuPont made money from selling CFCs. They found a substitute. And they were the only ones who knew how to make so-called HFCs. So what the Montreal Protocol essentially did was said, we're not going to use CFCs anymore, and any fool can make CFCs, and therefore this is low margin production, right? There's not a lot of money in CFCs. But only DuPont could make HFCs at a time. So essentially they got a monopoly temporarily on producing the substitute. And that is why Reagan switched and told his negotiators to change position. When the Europeans found out, and when the Japanese found out what really happened, they were extremely cross, right? Because there's also a very big European and Japanese companies in the chemicals, and I essentially said, can't use those words in class. We've given away the market, right? Essentially, is what happened. So that was important. That explains the political dynamics. But again, it's a cheap technological fix. HFCs are only slightly more expensive than CFCs, and they're almost as good, right? So you can solve the problem. And nowadays in your fridge, there's HFCs rather than CFCs, and you won't be able to tell the difference, right? So from a consumer perspective, nothing changed, right? And yes, they're slightly more expensive, but the cost of cooling liquid in your fridge is actually small relative to the rest of the fridge, right? This is not the major expense there. So yeah, consumers didn't mind. Everything continued to work as it did. Now this is true for the 24 countries that were there, right? Now why did the rest of the world sign up? There are two reasons for that, and the first are given here. India signed up not because they wanted to, but because they were given fairly substantial money and fairly substantial help with access to technologies. And that is why India signed up to this. China signed up for a very simple reason. China wanted to get into the World Trade Organization, and they said, well, first you have to sign up to the Montreal Protocol. And for China, even though they did not want the Montreal Protocol, they wanted to get into the World Trade Organization so badly that they just paid this price, right?
When was that?
Hmm?
When was that?
When?
When was when were they granted WTO?
Sorry?
What?
I was going to say 2001 as well, so around that time for sure. The final reason why the Montreal Protocol was such a success is because it had trade sanctions. So the Montreal Protocol did not just ban the consumption of CFCs, but it also banned in the signatory countries the production and the export of CFCs. So this was an export ban, not an import ban, right? Now, why is this important for small countries? So CFCs are not that hard to make. Anybody with a degree in chemical engineering can make CFCs. But to make them cheaply, you need economies of scale. So if you're a smallest country, let's say Ghana, you can make CFCs, you would have the necessary expertise in your country, but you only need a small amount, right? So they would be fairly expensive. So for smaller countries, it makes sense to import CFCs from other countries. But the major exporters all signed up to this export ban, right? So it doesn't help anymore. So for a small country without a domestic supply of CFCs, the choice is essentially make them yourselves, but then they would be expensive, or sign up to the Montreal Protocol. And the trade sanctions were actually such that we're first going to ban exports to non-signatories, and then later we're going to ban exports to the signatories as well. So essentially, yeah, you can use these CFCs for a low price through imports for a little while longer, and then switch to the HFCs and create a lot of environmental goodwill because you signed up to this international treaty. So for a small country like Ghana, these trade sanctions really, the export ban really seemed to work, and they signed up to this deal as well, right? And as I said, this only holds if you don't have the economies of scale, right? For China and India, as I said, they had to be bribed. Go ahead.
Sorry, I don't understand. They benefited from. How would they benefit from not being able to import it because exporting was banned? Is that, and then they signed up because they didn't have any choice?
Essentially the choice was, they didn't have a choice, right? The choice was not sign, and then you have to create a domestic industry to make these things. If you sign, you had access to the CFCs longer, and you would also have access to the HFCs.
So the agreement said that they could trade it with other people who signed in short term?
Yeah.
Okay.
And then, of course, for the exporters, it was the low value market versus the high value market, right? So this was successful. What is now being done, the problem with HFCs is that they're greenhouse gases. CFCs is greenhouse gases as well, but HFCs are stronger greenhouse gases than HFCs. So we solved the ozone problem, but we made the climate problem worse. And what we have is this international piece of international law that regulates HFCs, right? So this is now being used through the Kigali Amendment, and this is a view of Kigali, to also phase out HFCs, because by now we also have substitutes for HFCs with an even more complicated name. And this entered into force in the United States 3 weeks ago. And we're now using these ozone regulations to solve part of the climate problem, right? Which is an intriguing development. Now, what can we learn from this for climate? The reason that I paused was, oh my God, did I put this on the exam, yes or no? I don't recall. It was on the exam a few years ago. So what can we learn from this for climate, right? Maybe you guys are just lucky. So we have these two successful international agreements. We learn lessons from this for climate. Well, an important part of both acidification and the hole in the ozone layer was that there was a strong public demand, right? And the same is true for climate, right? If you survey people, then consistently over the last 20, 30 years, people have expressed a strong concern about climate change, right? So there is a strong public demand for a solution. In both cases, there was a cheap alternative that did not bother too many people. It was mostly industry doing things slightly differently, and most people would not notice that things were done differently. That is now beginning to emerge for climate, right? You don't care where the electricity comes from. As long as there is electricity, you don't care whether it's coal or gas or wind. As long as it's reliable and the grid is, as long as it's reliable and affordable, right? And that is now beginning to emerge, at least for electricity, in the form of solar and wind power. But we also said that for other forms of fossil fuels, actually I don't have quite such a good alternative yet. But it's beginning to emerge, right? For acid rain, essentially emissions came down for a whole bunch of reasons that had nothing to do with acidification policy. And that is something that I don't quite see happening for fossil fuels, right? So this lesson does not carry over. Probably the most important two things that we learned from the hole in the ozone layer is that the alternative came from the same suppliers. So DuPont gave up producing CFCs and started making more profitable HFCs, initially more profitable HFCs. What we do not see happening is that Saudi Arabia is going to give up producing oil and it's going to deliver solar power instead. They might want to, but no, we're putting the solar panels here, not in the Arabian desert, right? So DuPont had a good reason to advocate for environmental policy. Saudi Arabia does not. Russia does not. Australia does not, right? The big suppliers of oil and coal. Also, those trade sanctions that were in the Montreal Protocol were essentially the producers of CFCs said we're going to ban the export of CFCs. That doesn't work, right? Because again, this would be Russia saying we're no longer going to export oil. This would be Saudi Arabia saying we're no longer going to export oil. This would be Australia saying we're no longer going to export coal, right? That doesn't carry over, right? So yes, we had these things, but really you look at it closely, what were really the success factors for acidification in the hole in the ozone layer? That doesn't apply to climate change. So, unfortunate, this is a very unfortunate place to end, right? But this is where it ends.